Today we are going to conduct certain experiments. The first experiment is determination of the focal length of a concave mirror and convex lens by obtaining the image of a distant object. So here we are taking a concave mirror and convex lens. With the help of that, we'll be forming the image, and with the help of the formation of image, we are going to find the focal length. And you know, the entire thing depends on the mirror equation. For the concave mirror, we'll be following the mirror equation, which is 1 by v plus 1 by u equals to 1 by f, where v is the image distance, u is the object distance, and f is the focal length. We are talking about an object which is placed at infinity, at relatively large distance. So if the u is infinity, if the object is relatively at high distance, large distance, so we can put u as infinity. And if u is infinity, then you can find that f is equals to v. That means the image position will be the focal length of the concave mirror. So first of all, in this experiment, what we have to do, we have to take a distant object which is relatively at very large distance, and we'll be placing the concave mirror like that. So real image is formed at its focal plane. Real image is formed at its focal plane. That you have to understand. So in that case, all the rays are parallel rays, because if the object is at infinity, all the rays are parallel, incident rays are parallel. And each and every ray follows the laws of reflection. So afterwards, all the rays are converging at that point and real image is formed. Why the image is real image? Because the image is formed by the coincidence of real light rays. So image is inverted and real. Real images are always inverted. So with the help of this, we can find the focal length of a concave mirror. Now I can tell you how the image is formed. So here, this is the observation tables which is required to calculate the focal length of a concave mirror and convex lens. So first of all, I'll explain the observation table which is required to determine the focal length of a concave mirror. So in this case, you can find this is a serial number where you can write the number of readings. We have to take number of readings, 2 or 3 readings, such that we can take the average. And this is the position of the concave mirror. We have to find the position where the mirror is placed. And this is the position of the wide screen. This is a screen where the image is obtained. The real inverted image is obtained. So we have to note down the position of the mirror, as well as we have to note down the position of the wide screen. Definitely, the distance between this position of the mirror and the position of the screen where the image is formed, as I have already explained, that image is exactly formed in its focal plane. So that difference will give you the focal length of the concave mirror. And as to get the better accuracy, we have to conduct the experiment for, we can take several readings, and after that we can take the average reading. Similar table is required to find the focal length of a convex lens. In this case, we have to note down the position of the convex lens, similar to the previous case. We have to find the position of the wide screen, similar to the previous case, and the distance between them will definitely give the focal length of the convex lens. The apparatus which are required to conduct the experiment to determine the focal length by a concave mirror, we need an optical bench. This is an optical bench which is required to place the mirror as well as to place the screen. And in this scale, there is a marking, there is a scaling. The scaling is given in centimeter. So where we can place the mirror or where we can place the screen, it can easily be determined with the position, with their marked position. That distance can also be measured with the meter scale. So either we can take the reading from the optical bench, or we can take the reading with the help of meter scale. Now, another thing is required, that is concave mirror. The most essential thing is required, that is concave mirror. And this is a mirror stand where we can place the mirror. And this is the screen. Wide screen is used, and this screen is placed on a screen stand. So the apparatus required is a concave mirror, optical bench, and the stands by which we can get the readings, and a meter scale. This is a concave mirror which we have to place on the mirror stand. I have already placed the concave mirror in its stand. Now we have to take an luminous object which can be placed at relatively large distance, and we will try to focus the image at the screen. This is a torch which can be used as a luminous object, and the torch can be placed at relatively large distance, at very large distance, and we will try to focus the image of the light which is coming from the torch. as I have already told you, the torchlight is used as a luminous source, luminous object, which is placed at relatively large distance. And here you can see that image is already formed at the screen. Now this is not a very converged image. This is not a focused image. So now what we have to do, we have to fix the screen at its fixed position, and we'll be shifting the mirror. As I'm shifting the mirror, you can see the image is little bit focused now. And once we get the clear image, that would be the focal length. So here you can find, now we are getting very converged image, right? Now if I displace it more, again the image is blur. See, it is blur. That means we have to fix the position of the mirror where we get very clear image, very focused image. So now again we can displace the mirror. Once we get the clear image, focused image, again it is blurred. That means this is the position where the image is perfectly focused, Now we can take the reading either from the optical bench, or we can simply take the reading with the help of the meter scale. So we have to place the meter scale at its marked position, and we have to find the position of the lens. So it is almost 19.8 centimeter. It's 19.8 centimeter is the focal length of the mirror, because the image is formed exactly at its focal plane. Here you can find the screen is placed exactly at 20 centimeter, and the mirror is placed at 39.8 centimeter. From the marked position, we can take the reading. It is at 20, and that is 39.8. So the difference between them is 19.8 centimeter. And we have to repeat the same procedure for several times, at least for 3 times, such that we can take the average focal length, such that we can get more accurate reading. This is the observation table which is required to determine the focal length of concave mirror. Here you can find this is the position of the concave mirror, and this is the position of the wide screen, and this is the focal length. So initially the screen was placed at 20 centimeter, and the concave mirror was placed at 39.8 centimeter. The difference is 19.8 centimeter. Similarly, we have varied the position of the screen. Now the screen was placed at 25 centimeter. Automatically the position of the convex lens was also varied. It was 44.9 centimeter. The difference is 19.9 centimeter. And again the screen was moved to 30 centimeter. Again automatically the position of the concave mirror was changed to 49.8 centimeter, and the difference is 19.8 centimeter. So we have got 3 different readings of the focal length, and to find the average reading we have to add 19.8, 19.9 and 19.8 and divide it by 3, and it will be 19.83 centimeter. So we have to consider it as 19.8 centimeter, because the limit of accuracy of this device is 0.1 centimeter. The apparatus required to measure the focal length of a convex lens is basically, we require a convex lens, then we need a lens stand where you can place the lens. This is a screen where you can get the image. This is a screen stand where the screen is placed, and here we are using that candle as a luminous object which can be placed at relatively large distance. So first of all we have to place the lens at its position, and it is already placed. So now we are trying to find the clear image, the focused image at the screen. So in this experiment, here you can see that we are using candle as a luminous object which is placed at relatively large distance, and the image is formed in the screen. Now the image which is formed at this position of the lens, it is not very clear. That means it is a blur image. That means image is not formed at its focal point or focal plane. Now what we have to do, we have to displace the lens to find the most converged image, most focused image, and the clear image. Now as I am displacing to this side, the image is more blurred. That means we have to displace the lens towards the screen. And as I am displacing the lens towards the screen, you can find that a very clear real and inverted image will be formed when I'll be placing the lens exactly at its focal point. Now here you can see it is a little bit converged, but now again I can move it towards the screen. Now again it is blurred. That means we have to place the lens in between. Now again we will try to place the lens, and now you can see real inverted image is formed exactly on the screen. Now what we have to do? We have to find the position of the screen from the optical bench, which is exactly placed at 20 centimeter, and at the same time we have to find the position of the lens from its marked position in the optical bench, which is 14.5 centimeter, sorry 34.5 centimeter. The distance between them is the focal length of the lens, which is 34.5 minus 20, that is 14.5 centimeter. And we have to repeat the same procedure for 3 times such that we can take the average reading, such that we can get more accurate reading. This is the observation table which is required to determine the focal length of a convex lens. So here you can see initially the screen was placed at 20 centimeter and the lens was placed at 34.5 centimeter. The difference between them is 14.5 centimeter, which is the required focal length. Similarly, the position of the screen was varied to 25 centimeter. We have got another reading of the lens at 39.6 centimeter. The difference is 14.6 centimeter. Again, the position of the screen was varied to 30 centimeter, and automatically the position of the convex lens was also varied, and it was obtained at 44.6 centimeter. The difference is 14.6 centimeter. The average of these 3 quantities is 14.56 centimeter. So we have to take 14.5 centimeter because the limit of accuracy of this device is 0.1 centimeter. And this is how the focal length of a convex lens can be determined.